One more thing before I leave the finance example. Let's just talk a little bit about discounting. What we've been talking about today is how to calculate the future value of money. Now let's talk about discounting. And let's talk about it in both the discrete model and the continuous model. In the discrete model, we had this formula. The future value of money, let's say, put it in a financial context, is A times 1 plus I raised to the t power. And let's assume I is the annually compounded interest rate again. Let's go back to that. Okay. This V really represents the future value of money. The value of money at some time t in the future. The present value right now is A. Notice if t is 0, 1 plus I to the 0 power is just 1, then it's just A. So A is really the present value. For many problems, this will be the form you want to use, because for many problems you want to calculate the future value. But for other problems, you may already know the future value of the money, and you might want to calculate its present value. So if you don't know the present value, but you want to calculate it, you could just divide both sides of this equation by 1 plus I to the t power, and notice you would get this. A, the present value of money, is the future value, I'll leave off the t, divided by 1 plus I raised to the t power. Okay. For example, suppose you have a 0 coupon bond. A 0 coupon bond doesn't pay you any interest. This bond matures in 20 years, and it's going to pay you a certain amount. Okay. Suppose at the end of 20 years, this bond matures and pays you $2,000. Okay. How much is this worth? The future value is known. How much is this worth if the interest rate is 5%? Well, you just calculate this thing right here. 2,000 divided by 1.05 to the 20th power. And when you calculate this, you'll get the present value of the bond, what the bond is worth right now. And what would this be if you did this calculation? Anybody? What would the present value of a bond, a 0 coupon bond that matures in 20 years, be worth if the interest rate is 5%? Okay, so Heather, when you multiply, when you raise 1.05 to the 20th power, what do you get? 2.65. Carry it out a couple more digits. 3.2. Now divide 20,000 by that, and what do you get approximately? 7. Go ahead. 5.3. Point due to the nearest penny. 7.8. Okay. Okay. So what that's saying is the present value of this bond is only $753.78. If you were to sell this bond today, that's what you would get for it. Okay. Or another way of putting it, if you had $753.78 today, if you had that much today, what would it be worth in 20 years? assuming the interest rate is 5%. Michael? 2,000. Now, there may be a little bit of round-off error there, but ignoring the round-off error, if you start off with this much, at the end of 20 years, $753.78 should be worth $2,000. Okay. And that's the idea of discounting. That's discounting in the discrete model. Okay. The simple idea here is money received in the future is not worth as much as money that you have right now. Because if you had the money right now, you could invest it at compound interest, and it would become worth more in the future. Okay, so money received in the future has to be discounted to convert it into present value terms. Okay. Now, this is the discrete model. There's a similar model for continuous growth. For the continuous growth model, you have this. The future value of money, let's say, is A times e to the RT power. The present value would be this. If you solve for A would just be V divided by e to the RT power. Or alternatively, we could write this as A equals V times e to the minus RT power. And this formula would give you the present value of V dollars received 2 years from now at a continuously compounded interest rate of R. So if you're doing present value, you have to multiply the future value by e to the minus RT. You have to discount the future sum. Okay. And this, again, let me erase this. This is for the continuous model, obviously. Continuous growth model. So anytime you see R in this class, it is the instantaneous growth rate of V, and it's assuming continuous growth. Anytime you see I, that's discrete growth model. Okay. For some processes, it certainly makes more sense to assume continuous growth. I mentioned earlier, for something like population doesn't grow really discretely. It's really growing continuously. Because in a large country, some woman is giving birth almost every instant. So really, continuous growth in this context makes a lot more sense than discrete growth. If you think of GDP, gross domestic product, in economics, that's being generated more or less continuously. So this continuous growth model is the one that's generally used when you're talking about population, when you're talking about economic growth. It's usually a continuous process.